Right, so saying we ended on question 3. So today we're going to start with question 4. So question 4 is saying by using the first principle, find the derivative in terms of x when the function of x is equal to 3x squared. So first of all, what you need to understand here, you need to know how the the first principle formula is. You need to know what it looks like. So according to the first principle, we know that you find the dy dx, rather you find the gradient function, or you find the derivative. The derivative of a given function is sometimes called the gradient function because you use the first the derivative of the first order to find the gradient of any given function. So let's take, for instance, this one here. So it's saying f of x is equal to that. So I said you first have to know how the derivative, how the first principle looks like. So it says that given the function f of x, to find dy dx of, or to find the f of x dx. Now in this case, I'm using dy dx because I know it's the one that most people are used to. So I'll say if my function is equal to y, and then this side I have the function f of x. So to find dy dx, you have to take the limit. So in short, the first principle just uses the limits to find the derivatives. So you are going to find the limit, the limit of that given function when h is approaching 0. Yeah. So where you say f, you first find the f of h plus x. First find the f of x plus x, and then you subtract that same given function f of x. Then after subtracting, you divide everything by h. So this h is supposed to be approaching 0. But remember what I said in the previous tutorial that we had? I said always when you are dealing with limits, you should avoid a situation where you have a number on top there, and then here you have a 0 as your denominator. So this is the situation that you are going to be avoiding always. So in this case, when you find the limit when h is approaching 0, you discover that here your denominator will be 0. So in short, you're going to find means and ways in which you're going to make your denominator not to be 0. So how do we do that? So in short, this is the formula for the first principle. This is the formula for the first principle. So we can try here. So what we do when you have a given question like this, then you've been told to find the derivative of this. So in short, you're going to have, you are going to be finding the f of x dx. So it's going to be like this: the f of x, and then dx is just going to be found by taking the limit of so f over h plus x. In short, we're trying to say that where there is x in this expression, replace with h plus x. So I'm going to write my function there, and then where there is x, I'm going to replace with h plus x. This is what I'm going to do. And then you can see here the function is coming back, or subtracting the function from that. So I'm going to have my 3x there, my 3x squared there. And then this is also supposed to be squared because x here is squared. And then we're taking this limit when h is approaching, when h is approaching 0. When h is approaching 0. Yeah, and then you divide everything by h. So what you do here is simplify this expression on top. So the expression there on top is going to be 3. Then when you simplify, when you expand this, you're going to have h squared, then you have x squared, then you have 2xh, and then, yeah, I think that's so. This is what you're going to have when you expand that. And then you're going to have minus 3x squared this side. Then everything divided by h. Then you are taking the limit of this when h is approaching 0. When h is approaching 0, like that. So proceed. So here what you do again, the next step here, you're going to multiply this 3 throughout there. Then you can see that when I multiply this 3 times x squared, and then I come and subtract with this x squared, I'm going to get a 0. So in short, what I'm going to remain with on top there will just be the limit. So when h is approaching 0, the limit of this, so I'm going to remain with 3 times h squared, which is 3h squared, and then 3 times 2xh, I'm going to have plus 6h, 6hx, which is again divided by h. Then we can see that this h is now cancelling with one h there, and then with that h. So in short, we're remaining with the limit of when h is approaching 0. So we're going to remain with 3h, and then plus plus 6h, 6x. So this is what we're going to remain with. And then remember what I said, when you're finding the limit of a given function, when a particular variable is approaching any given number, you just replace that number on that variable. So in this case, we're just going to be replacing 0 where there's h. So we're going to replace 0 where there's h. So in short, we're going to have our answer to be, when you put 0 where there's h there, we're going to have 3 times 0, which gives you 0. 0 plus 6h, 6x, you just have your 6s as your answer there. So that 6s is the derivative of this function. So this is what they wanted. Means that you have used the first principle. Of course, there's a short method of doing this, but in this case, we're restricted to use the first principle. But there is also the power rule, which is you just apply this 2 times 3 there, you get your 6, and then you subtract these the power there, subtract it by 1. So you're going to say 2 minus 1 there, you remain with 1 as your power there, which is just the same as just writing 6x. Then you find your 6x like that. So the one that I've used here, the short form, is called the power rule. And then this, which they've told us to use, is called the first principle. So since we've been taught to use the first principle, we're restricted, we just have to use it. But if they just said, find the derivative of this, it's better you use the shortest form here, where you just multiply the constant, the number there with the power, and then subtract the power by 1. So we can proceed. I just hope that you've gotten the concept here. What is important is getting the concept. Let me just erase everything here. Okay, let me just do this. And I don't want to erase the formula again. Okay. So we proceed with the next question there. The next question, again, you solve it in the same way I've solved these questions. I mean, this first question. All you need to know is the formula for the first principle. Once you know that, you never get any question wrong. So the second question here is saying f of x is equal to that. So we first have to find f of h plus x, meaning in this expression that we've been given here, where there's x, you put h plus x. So when you get this expression, you are going to have, so in short, we're going to be finding the limit of that when h is approaching 0. So we're going to say 1 over, where there is x there on the denominator, we're going to replace with x plus h. And then you say minus, you sorry, I've forgotten to put a minus 1 this side. Then minus, you repeat the same function here, which is f of x. So it's going to be 1 over x minus 1. Then everything divided by h. So what you do here, you simplify that expression again the way I just simplified the previous question. And then from there, you're going to get your answer as, from there you're going to get your answer. Yeah, you just have to simplify this. So let me just give you the solution, the final solution, so that when you have time, you can solve it on your own and get the solution. So the final solution, when you simplify this, and find the limit of that, you are going to get -1, and then everything divided by. So if you have time, solve through this question, and then get this solution. The reason why I've just written the answer there, it's a long process. When I start solving it, we're going to spend the whole maybe 20 or 30 minutes just solving one question. So I've just decided to solve it on a separate paper. Yeah. So this is the answer that you're going to get when you simplify that expression. So find time to simplify it and see if you're going to get the same answer as this. All right, so let us also do another question. Let me do this one. Let me just get
Mr. Teddy.
Yeah.
Mr. Teddy.
I'm getting you.
So there you are adding. So there you are adding h plus the expression for the function of x.
You are saying?
I'm saying on the first part of the principle there.
On this part here, which is 1 over x plus h minus 1.
F of x.
So what you do here, while there's x, while there's x, you replace with x plus h on the normal function here. So while there's x, this x here, you replace with x plus h. That's what I'm doing. It's like when you're given maybe a given function like f of x is equal to, maybe f of x is equal to maybe 2x, and then they tell you to find f of 1. So f of 1, we just replace 1 while there's x there. You just replace 1 where there's x. This is what I was doing. When you look at this part here, it's just finding f of h plus x, meaning while there's x, you just put h plus x. Okay, let us do this one as well. I'm sure you understand it better as we do more questions on this same question. So let me just erase this. Okay. So we are saying f of x is equal to cos 3x plus cos 3x. So again, while there's x, we're going to replace with h plus x. In this cos 3x, while there's x, I'm going to replace with h plus x. So where there's x, I'm going to put, so in short, I'm finding the limit. I'm finding the limit of that when h is approaching 0. So where there is x in that equation, I'm going to replace with h plus x. Like that. And then I'll subtract the whole function again from that. So I'm going to have cos 3x this side. And then everything divided by h. So this can also be simplified as the limit when h is approaching 0 of cos, I'll open the brackets and then I'll write 3h then plus 3x and then minus cos 3x. Everything divided by h. So again, what you do here, you can see that this cos 3h plus 3x, we can use the compound angle formula to simplify this. You can see that we learned that on trigonometry. So it's easier for us to use it now. We're just applying it. So here we're going to have something like this. So on cos 3h plus 3x, I'm going to replace with the compound angle formula for that, which is cos 3h, and then I'm going to also have cos 3x, and then minus sine 3x, sine 3h, sine 3x, and then I'm going to subtract everything, cos 3x. So that is cos 3x. And then we divide everything by h. Yeah, we divide everything by h. So what you do here, you can see, and then I forgot to show you some, I'm sure you saw them in your module. Yeah, because I saw something like this in your module. I forgot to show you some special limits. So when you're finding the limit of sine x over sine x over x when x is approaching 0. When x is approaching 0, this is just equal to 1. And then you have also the limit of cos x minus 1, cos x minus 1 over x. This one is equal to 0 when x is approaching 0. So these are special limits. You can master them. You can master them. And then what you do again, here from here, so what you do is you factorize and see that it's we have this cos 3x, which is common. So even before we factorize first, because I know that there are these trig, limit identities which you need to know. So if I want to make if I want to make something look in this way, it means that if there's x in there, if there's x there as the angle, the denominator here is also supposed to be x. So in short, what I'm trying to say is if there is a 3h there, it means that the denominator also here is supposed to be 3h. And how can I achieve that? It's by multiplying everything by 3 over 3. So when I multiply everything by 3 over 3, I'm going to have this 3. Let me just write them there. Then there's also going to be a 3 there. There's also going to be a 3 there. And then the denominator will also be 3 there. So this is what I'm going to have. So what I've done here is just the same as adding nothing to this. When I divide this 3 into everything there, I'll go back to the same expression which I had. So after having this, we can now simplify this. We can now simplify this by factorizing 3x. We know that 3x is common there. So when cos 3x is common. When I factorize cos 3x, I'm going to have something like this, cos 3x. I'm going to have cos 3x like that. And then open brackets. We can see that this cos 3x, there's this cos 3x there. There's also that cos 3x there. So when I factorize, I'm going to get, let me just remove the 3 as well outside. So I'm going to get something like, I'm going to get something like, so someone is asking for me to repeat why I added 3 over 3. So in short, what I'm trying to say, when you look at this part here, these limits here, these limits, I'm saying they are special limits. When you look at them, you have x here, you have sin x there on top, you also have the denominator x there. So meaning, if you want to achieve something like this, you need to have a situation where if this is x, if you have the angle x there, the denominator also is supposed to be x. So now when you look at these expressions which we have here, the angles there, we have the angle there 3x, we have the angle there 3h, but the denominator there is h. So I wanted to make this h also to be 3h. Hence I multiplied the numerator and the denominator by 3, which is just the same as doing nothing, which is just the same as multiplying them by 1. The numerator, I multiply the numerator and the denominator by 3. So I wanted to make this h to be 3h, such that at some point I'll be able to get what I need. Okay, so let us write now this. So I'm going to have 3h there, cos 3h. I'm going to have cos 3h. Cos 3h and then minus 1 there. Then open brackets, the space here is too small, so I'm just going to write a minus there, and then I'll proceed from this side. And then of course everything here is divided by 3h, and I'll proceed, this minus there is this minus here, so I'll proceed and then I'll say 3 sine 3h and then sine 3x. and then everything divided by, so everything divided by 3h. So you can see our identities have now been achieved. So where you say cos 3h minus 1 over 3h is just the same as cos x minus 1 over x, which is 0. So when I replace 0 there, I'm going to have 0 times 3 cos 3x. So 0 times 3 cos 3x, I'll get a 0 there. And then I'll say minus. Here we can see that there is sine 3h. There is this part here, which is sine 3h over 3h, which is just the same as sine x over x, which is just the same as 1 there. So on this part, I can replace with 1. So 1 times 3 times sine 3x, I'm just going to get 3 sine 3x, like that, which gives me my derivative to be just negative 3 sine 3x. So the derivative of cos 3x using the first principle is just nothing but negative 3 sine 3x. So these two identities here are very important. They are very important. You need to know them. And then we proceed. Okay, let me just erase this quickly. Oh, I'm sure by now you know the formula for the first principle, so let me just remove everything, because erasing them one by one will take us a lot of time. Then let us look at this one here. This one is also a long process thing, but we can make it short. Yeah, and then I forgot to tell you one thing. On this one, when you're using the power rule to find the derivative of this, when you're using the power rule to find the derivative of that, you just say divide the x of cos 3x. We know that it's negative sine x. So since we have 3x there, you say negative sine 3x, and then you just find the derivative of the given function here. The derivative of 3x is 3, so you just multiply it with that. So this is the answer that we found there. So using the power rule, using chain's rule, you get this very quickly. Okay, so we proceed. Let us also find D. So on D there, using the first principle, again, where there is x, you can replace with h plus x. So you're going to find the limit. To find the derivative of this, you're going to find the limit when h is approaching 0. So the limit of this function when h is approaching 0. So first you find f of x plus h, meaning when there's x there, you're going to replace with h plus x. So you're going to have something like this, h plus x, and then you square this, then plus 1, then minus the same function, you repeat it, x squared plus 1, then you divide everything by h. So if you remember very well in the first lesson we had yesterday, when you have such a thing, you just have to find the conjugate. So meaning you're going to multiply both the numerator and the denominator with the conjugate. Yeah. So the conjugate of that is just going to have a different sign in between there, meaning you're repeating the same things, but you put the different sign in between there. So you're going to have x plus h, and then plus 1 this side. And then this side again, you're going to have, this is squared. So again, this side we're going to have x squared plus 1. Yeah, so even on the denominator, you do the same. We're going to have x plus h, then squared plus 1. And then even there, you have the same things, x squared plus 1. So here it's just a matter of multiplying them. You know that when you multiply this and that, you get, anyway, I'm sure maybe you guys can simplify this. This is also a long process, but I would like you guys to be doing these questions that I'm leaving. You do them on the separate paper and then forward them to me on WhatsApp. I check whether you are correct or wrong. And then if you are wrong, I'll control you. I'll send you a voice note explaining where you've gotten it wrong. And if you are correct, I'll tell you that you are correct. So I want you to go and simplify this as well. So meaning you have two things, this one here and this one there. You simplify them. Then after simplifying them, make sure that you get your solution as the solution is supposed to come out as this. So this should be your answer. So just write this somewhere. Make sure that you get this as your answer when you simplify that. And after simplifying, take the limit when h is approaching 0. So this is supposed to be your answer when you simplify that. There's supposed to be squared here. So try to go and simplify this and then write it on a separate paper and then forward the picture to me on WhatsApp. I'll tell you whether you are correct or wrong. Then if you completely fail, I'm going to send you the solution of a picture that I've solved this question on. So we proceed with this one here, which is just the same. So where there's x there, you put x plus h. I'm remaining with 5 minutes. Let me just summarize these two questions. So where there is x, I'm going to put h plus x. Then I'll subtract the whole function by 1. I'll subtract the whole function by 1 over x. So I'm taking the limit when I'm taking the limit of that when h is approaching 0. Then everything you divide them by h. So when you simplify that and take the limit when h is approaching 0, this is h. You simplify that on the numerator there, you're going to have something like negative h, then everything over h. Yeah, just even by looking there, you can see how it's getting simplified like this, something like this. So you can be solving through these questions at your own time and then forward to me your solutions. I'll tell you where you've gotten it wrong or correct. So you can see that this h and that h is cancelling. So remaining with just, remaining with this negative 1, and then over, you're going to have x, and then while there is h, you are taking the limit when h is approaching 0. So meaning while there is h, you put 0. So when you add 0 plus x, you still have x. So you have your x there. And then this is going to be your final solution. So this is going to be your answer. Negative 1 over x squared. In this remaining last minute, let me just also show you how to solve the last question there, so that when we come back in the next session, I'm going to send the link just after this session. I'm going to send another link. When we come back in the next session, we'll do question 5. So Let me also show you how to solve this one. So how to solve this one is just similar the way we have been solving these other questions. While there is x there, you put x plus h. So you're taking the limit when h is approaching 0, and then you have where there's x there, you put x plus h, and then everything divided by where there's x, you put x plus h, and then you say minus, you subtract the same function again. Yeah, there was a network problem. So I was saying you where there's and then you repeat the same function here. You repeat the same function and then you divide everything by h. That's how the first principle is. And then here it's just a matter of simplifying the expression as well. You simplify the expression, and then after simplifying, you get your answer to be, you simplify your expression, then where there is x, you replace with, where there is h, you replace with 0. You're going to have your final answer to be negative 2x minus 1. Then everything.
Down there, -1.
Hello?
Hello, I'm saying down there on x plus h divided by x plus h.
Oh yeah, it's supposed to be negative 1. So we're done with product rule. We can now move on to quotient rule. So quotient rule, okay, let me just erase everything here. So quotient rule, you know that when you're finding a quotient, we know that when you're finding a quotient is simply, or a quotient is simply a number that is found, or is simply the answer that is found after dividing two functions. So quotient rule is simply a number or the answer that is found after dividing two functions. So quotient rule states that if you have your function y being equal to u over v, you are going to have your dy dx. Your dy dx is going to be equal to v u prime. Remember what I said? I said u prime is just the same as the u dx. And then you say minus u, and then v prime. And then everything divided by v squared. Everything divided by v squared. So what you do here again, you use, okay, let me get one example. Example, which one can I get? Which one? Okay, let me get this one. We can see that there are two functions which are dividing themselves. Of course, even this one, you use quotient at some point, but this one is involving quotient, chain rule, yeah, and power rule. Even this one, it's involving quotient, power rule, and chain rule. But this one is just chain rule. This one, quotient, power rule, and then you also have chain rule. This one is product, product and chain rule. This one is just product and power rule. Yeah. So we begin now. So which one is our u in this case? Our u will be the numerator there. So I'll say let my u be equal to, so I'm solving this question here. My u will be equal to the root of 1 plus x squared or x cubed. And then my v is going to be equal to the denominator there, which is x squared. So this one we know to say, yeah, for us to use this quotient rule, we need first to find u prime and v prime. So before you find u prime, you can simplify this u prime in this form. You can write it in this form, which is just 1 plus x to the power 3 and then this raised to power half. We know that the third is equivalent to 1 over 2. This square root is just equivalent to 1 over 2. So for us to find u prime there, so u prime will just give us what? You multiply this half times 1 here. Half times 1, you get half. I'm using quotient, Chain's rule here. Then open brackets, you are going to have what is in the brackets there. You repeat them, you write them. This is going to give you x to the power 3. And then you subtract the power there. You subtract 1 from the power. So meaning this will give you half minus 1. You eventually get negative half. And then multiply everything with the derivative of what is in the brackets there. So the derivative of what is in the brackets using the power rule, when you look at this 1 is a constant. When you differentiate 1, you get 0. So it's just the same as not writing it. And then when you differentiate this x to the power 3, you are going to get, using the power rule, you get 3x squared, like that. So this is our u prime. So in other ways, we can write this u prime as 1 over, sorry, instead of writing 1, let me write, when you multiply this one with 3x squared, you are going to have your numerator to be 3x squared. And then your denominator there, since this is negative, we want to make it a positive. So it's going to be the root of 1 plus x to the power 3. So that's what we're going to have. So this is your u prime. So now let us find v prime. So our v prime is simple there. We just need to use the power rule. So v prime is equal to this 2 times 1 there. What? I didn't get you.
Where has the 2 gone?
Repeat your question again.
Where has the 2 gone?
Oh yeah, this 2. Thank you very much. We forgot to put this 2 there. It's 1 over 2. So we can write it now. We can write our v prime here as 2x. Yeah. So we now just replace them in the formula. So the formula there is going to give us. We're going to get something like this. Divide x is now going to be equal to, what is v? I'll put my v there, which is x squared. What is u prime? I'll put that. So u prime, I'm going to put 3x squared, then everything divided by 2, and then the root of 1 plus x to the power 3. Then you say minus your u there, u is x squared. U is root of 1 plus x to the power 3. And then you multiply it with your v prime. So v prime is so I was saying, yeah, the v prime there is just 2x, and then you divide everything. You divide everything by v squared. So which one is our v? Our v is x squared. So you're going to say x squared, and then you square this x squared. So even this one, you can simplify it. if you want, yeah, you can simplify it. Actually, this one, you need to simplify it. Yeah. So let's also look at another question. So this is the quotient rule. This is basically the quotient rule. So actually, we're even done with the rules that I saw in the module. Yeah, these are the basic rules that you need to know as a person who is doing mathematics. Yeah, you need to know these basic rules on calculus. So now we can apply these same rules to answer the remaining questions. Let us try to solve let's try to solve a few questions there. So let us look at the properties of line. The properties of line when you are solving questions is the first property. Okay, let me show you the property of line, then I'll show you the property of trig ratios. Yeah. So the property of line when you're solving, when you're finding the derivative of it, is when you've been given maybe the function is equal to y is equal to the line. I'll call the function of line as u. The function of this line as u. Let me just write it. So when you've been given something like this, line u, to find dy dx of line u, dy dx of line u is nothing but you find the derivative of this. So the derivative of u is just nothing but u prime, and then over the original function, which is u. So what am I trying to say? So when you're finding this, when you're finding the derivative of this whole function, it means that you first have to find the derivative of what is in the brackets. So what is in the brackets there? To find the derivative of that, you need to use quotient rule. So you find the derivative of what is in the brackets by using quotient rule, and then divide by the whole function. So let us try to differentiate this one. Or maybe first, let me give you all the rules before we start differentiating the function. So the property of line, yeah, is that you differentiate the given function and then divide by that same function. And then, so this is line. Then let us also go on trig ratios. So, or before I go on trig ratios, let me also look at this special logarithm, which is e, when you have something like y is equal to e to the power the function u. So to find dy dx of this, you just have to differentiate the function there. So you find the derivative of that function and then multiply with this same e to the power u. So for instance, when you've been given a function, let me give some example here, which is y is equal to maybe e to the power 2x. It means that to find y prime here, which is dy dx, y prime is just found by, you differentiate the power there, you get 2, and then you repeat the same e to the power 2x. Let me also give an example on line. When you have y is equal to line x. So y is equal to line x. So meaning when you're finding y prime there, you differentiate x. When you differentiate x, you get 1, and then divide by the whole function there, which is x. So y prime of line x is just 1 over x. Let us move on to trig ratios now. So when you have y is equal to sine theta, or let me say sine x, okay, let me say sine x. So you are going to have your y prime here, which is dy dx. So your y prime is going to be cos x. That's the way it is. When you use the first principle, you can try this one using the first principle. You're going to get cos x as your answer. And then, meaning the opposite is the case. When you have y being equal to cos x, yeah, the opposite is also true for this one. So y is equal to cos x is, so to find y prime, we're going to get, instead of getting a positive sign, we're going to get a negative sine x. You remember what we found there? We had cos 3x, and then we found our answer to be 3 cos 3x. So for instance, let me also give an example. When you have maybe your y being equal to sine 3x, or sine any number times x, or sine any given function there. So meaning you differentiate the function which you've been given there to find your y prime. You differentiate the function which you've been given there. So when you differentiate 3x, you are going to get 3, and then you write your cos 3x behind there, cos 3x. So that is going to be your solution. So same applies to this second part here. When you have maybe your y being equal to cos, when you have, what we're using to find these derivatives of trig ratios is chain rule. So you can see that if we say to find u prime, to find u prime, I mean y prime, using chain rule. So if we say that this 3x here is okay, let me just write here. If we have y is equal to cos u. So what I've been just doing all along is starting from this one here, starting from this part here, we use chain rule. Now that was just a direct method. I didn't just tell you that it's chain rule. Because for some of you, if I said let us use chain rule, you have said no, number at least, but anyway, this is chain rule. Second part here, it is also chain rule. Third part here, it's also chain rule. Even this side is chain rule. Now I'm telling you, we'll be using chain rule. Yeah, okay. So chain rule is just as simple as this. I know the time I was teaching it, you thought it was very difficult. So if we say cos u, I mean we say our u is equal to 3x, meaning our u prime is going to be equal to, or our du dx is going to be equal to, it's going to be equal to 3. And then when you find the dy du this side, you are going to get negative sine dy du. You are going to get negative sine u. So now when we put that in the chain rule, which says this is just the same as du dx. So du dx is 3. Then we multiply 3 times dy du, which is negative sine u. Negative sine u. We'll get our answer for our y prime to be equal to negative 3 sine. We know that our u there, we said u is just equal to 3x. So negative sine 3x there. So in short, what I've just been using, starting from this part here, the first part which I was explaining here is chain rule. So there's nothing hard about chain rule. So calculus, this is how simple calculus is. You can see how simple it is. So we proceed now to let me now solve a few questions from here, then we will call it a day. Okay, so you can see that this is ln, we're using ln, so meaning for us to find this, the derivative of this, of ln this, means that we first have to differentiate this and then divide by the original function. So when we differentiate this using quotient, because we're dividing two functions here, so meaning we're going to use quotient rule. So in short, to find y prime, we first have to differentiate this. So when we differentiate this, we're going to say our v. So our v there is 1 plus x squared. V times u prime meaning we're going to differentiate the top part there, u prime. So when you differentiate the top part there, we'll get negative 2x as our derivative. And then we say minus, and then u, you write your u is 1 minus x squared, and then your v prime there, v prime, you differentiate the denominator there. You differentiate the denominator there, you get your answer to be 2x, like that, and then divide everything by the denominator squared, which is v squared. So 1 plus x squared, and then divide everything by squared, by, yeah, that v squared. So here is just a matter of simplifying this. And then since we are finding y prime, meaning after differentiating this using chains rule, we have to divide by the original function. So when we divide that by the original function, we are going to have 1 minus x squared over 1 plus x squared. So when we divide this function by that, is just the same as multiplying it with the reciprocal of that. So we reciprocate this, and then we'll have something like this. This is what we're going to have. So we multiply this times that to find y prime. So y prime is nothing but equal to, so we can see that, yeah, we can multiply it through by this, or we can, what should be, okay. I wanted to reduce it at least. Now, let us just take it the way it is. So you simplify the top part there, you're going to have negative 2x. Anyway, let me just write that. When you multiply everything there, you're going to have negative 2x, then minus 2x to the power 3, and then minus 2x, and then plus 2x to the power 3. Yeah, so this is what I'm going to have. And then all these divided by x minus 1 multiplied by x. Okay, when you multiply this 1 minus x, or not x minus 1, it's supposed to be 1 minus x, sorry. So this is 1 minus x, and then we have 1 minus x squared, then we have 1 plus x squared, like that. Since when you multiply this times everything there, it's just the same as saying 1 plus x squared cancels with that 1 plus x squared on top. Then you multiply them with that. So this is what you're going to have. And then you just simplify the top part there. You can see that that and that is subtracting. Then you have your final answer then being equal to negative 4x. Then over that 1 plus x squared multiplied by 1 minus x squared. So this is going to be your answer when you find your u prime. So this is the answer for this question here. It's just as simple as that. We've already answered this one, so I'm skipping
Mr.
it.
Ted.
Okay.
Oh, Mr. Ted.
Uh-huh.
Now, what would be the difference if there wasn't a lien there? The way you've solved it.
If there wasn't if there wasn't a lien, it means that we wouldn't have put this. This part was not supposed to be there. You get?
Oh. No, I don't really get that part.
Oh yeah. So in short, what we said when you're finding, let me just explain the property of the lien. When you have y is equal to lien u, we said to find y prime. Sorry, let me just write this properly. Okay. So to find y prime, you just get the derivative of this u, the derivative of that u, and then divide by u. So in short, we got the derivative of this u and then divide by the same u. Yeah, so the division of this is just the same as the reciprocal of what is there in the bracket. It's just the same as multiplying with the reciprocal of that. So that's what we mean. Okay, so we can proceed. So we're done with that question. Let's also try to look at. So when you look, okay.
On the same one you've removed, so there is no need of multiplying with that reciprocal. You have to put that other side.
No, I multiplied it.
Mm-hmm.
Yeah, I multiplied it. Yeah, it's just that I've erased. Okay, you watched the video. I've explained. Maybe you didn't just get the time I was multiplying them. Watch the. I'm going to send this video. You watch it. You're going to see how I did the multiplication. So same applies. What I've done here is what is supposed to be done here, where you differentiate this using chains rule. Differentiate this using chains rule, and then divide by this same thing. Yeah, you differentiate this and then divide by this same thing. So here we are using product rule. Here we're using product rule. So for product rule, we know to say when you're finding y prime, you differentiate. First, product rule is, product rule states this: v u prime and then plus u v prime. So my u there will be this, and then my v will be e to the power negative 3x. So to find our y prime using product rule there, we're going to say v. So v will just be e to the power negative 3x times u prime. So times my u prime is just the derivative of that, which is 2x, and then I'll say plus, and then you say u. My u is x squared, and then multiplied by the derivative of e to the power negative 3. Remember what we said: when you have e to the power any number there or any function, we said to find the derivative of this, you just differentiate the power there. You get, so when you differentiate the power there, you get negative 3, and then you repeat the same e to the power negative 3x. This is also chains rule. When you use the chains rule method, you get this answer. So you multiply with that. Sorry, this is supposed to be, it is supposed to start with negative 3. and then e to the power negative 3x, like that. So this is what you're going to get as your product through method. So here you just now have to multiply this properly. So you get 2x e raised to power negative 3x, and then you have plus, this is going to be, sorry, it's going to be minus, because that 3 is a negative 3. So it's going to be negative 3 x squared, and then e raised to power negative 3x. So this is what you're going to have as your answer on that question. So we proceed to the next question. This one here, you use chains rule. In most cases, the trig ratio is just use chains rule. So to use chains rule on this one, you can say let my u be equal to x to the power 3. I wanted to use it directly. Now I know I may confuse some people. Let me just use it perfectly in the way that it's used. So let my u be equal to that, meaning my y will just be equal to cos u. So we can now find du dx there. So du dx, which is just u prime, is going to be equal to it's going to be equal to 3x squared. This is a constant, so it will give you a 0 when you differentiate it. So we move on to the next part there. You find dy du. So dy du is nothing but when you differentiate cos using the first principle, you know that you get negative sine u. When you differentiate cos u, you get negative sine u. So using the chains rule, you can combine the two. So to find y prime, using chains rule, you combine the two, you just multiply them. So you're going to have 3x squared multiplied by negative sine u. Yeah, so we just simplify this. You are going to have this. So where there is u, you replace with what you had equated to u there. So we're going to say this final answer is going to be negative 3x squared. And then sine, where there is u, I put my x to the power 3 minus 4. So this is going to be my derivative for this expression there. And then so I said I wanted to do it directly. So doing this directly is just the same as saying you say my y prime is equal to, you differentiate what's in the brackets there, you get 3x squared, and then 3x squared, multiply it with the derivative of cos. The derivative of cos is negative sine theta. So our theta there is x cubed minus 3. I mean minus 4. You can see that I'm still getting the same answer. When you multiply this, you still go back to that. So it's just as simple as that. So you should make sure that you know chains rule in your heart. You know it by heart, because you mostly it's the one that is mostly used when differentiating a lot of functions. So we can proceed to the next question. So this one again is straightforward. You just differentiate what is in the brackets there and then divide by the original function. So we can see there to say this we can either use product rule, or if not product rule, we can use quotient rule to differentiate this. How am I going to use product rule? Let me, because so far you know that we can use quotient rule since we are dividing two functions, but let me also use product rule on this one. even this one, if you just know how to differentiate functions well, you can use product rule as well instead of quotient rule. It also applies to this one. So to differentiate this, we know that to find the derivative of ln u, you first have to, so to find the derivative of ln u, I don't know why I'm writing in, okay, let me just do this. If y is equal to ln u, we know that if y is equal to ln u, we know that y prime is just found by u prime over the original function u. So same applies to this. My y, this y can also be written in a product form instead of in a quotient form. So it's going to be written as ln of e to the power x squared, and then times x to the power negative 2. So here I can differentiate this using product rule, and then after using product rule, and then I'm going to divide my answer by this expression. So I differentiate this using product rule. I'm going to have my y prime being equal to, you get this as your u and then this as your v. So you're going to have u, you can either start, for product rule, since we know that addition is commutative, you can start with anyone. You can start with any of the functions. But for quotient rule, you always start with v. Subtraction is not commutative. So you say, you can start with that and then differentiate this part. So you get, when you differentiate that part, you get negative 2x to the power, negative 2 minus 1, you get negative 3 there. And then you say plus, you write this function x to the power negative 2, and then differentiate this function here. So when differentiating this function using chains rule, we know that you're supposed to first differentiate the power. So when you differentiate the power, you get 2x, and then you repeat the same e to the power x squared. So, and then after doing this, you divide everything by the original function, which is e x squared over x to the power 2, which is just the same as this. So that can also be written as that squared multiplied by x to the power negative 2. So yeah, so here it's even now easier. You can just simplify this. You know that this x to the power negative 2 is there, so you can cancel with that. And then you can also cancel this x to the power negative 2 with that. Then this x to the power 2 can cancel with that and that. And then you see what you're going to remain with as your answer. So this question is also as simple as that. Yeah. We move on to the last question. So on the last question, this is the question that a lot of people normally get wrong when they are given such a question, because here it's not easy for you to tell that there is also product rule here. A lot of people would just use chains rule and forget. So in this question, you are required to use power rule. In this question here, it's the one that I'm talking about. You are required to use power rule. You are required to use quotient. You are sorry, not quotient. You are required to use power rule, chains rule, and product rule. So let's see how those rules are used to find the derivative of this question. So our u is given, our y is given as that. So to find y, this can also be split into 2. So this y is just the same. This cos squared x, this cos squared x cubed minus 4 can also be written as cos x cubed minus 4, and then multiply this by another cos, cos x cubed minus 4. So this is a product rule. We're multiplying two functions. We have this function and this other function here. So we're multiplying them, so we need to use product rule. So y is equal to, so we write this first using product rule. So meaning we write our u here. We write our u, meaning we're writing that cos x to the power 3 minus 4 in brackets. Then you have this multiplied by the derivative of your v. So the derivative of your v there is we found this to be negative sign, and I mean we found it to be, let me just write, I don't know if you remember how we found it, if you remember the answer that we found here, but this is equal to negative 3x squared. Even if you don't remember, you just differentiate what is in the brackets there, then multiply it with the derivative of cos x. So sine x cubed minus 4. So you have something like this, and then plus, again you repeat the same thing, cos, you repeat your v in this case now, cos x cubed minus 4 multiplied by the derivative of your u, which is just the same. So I'm multiplying it with that. It's going to be negative 3x squared, and then sine everything there, which is x to the power 3 minus 4. Like that. So we have now this, this can be simplified as this is going to be negative 3x squared, and then here we are going to have cos x cubed minus 4, and then you have sine x cubed minus 4, like that. Same applies to this. So instead of having a plus there, we have a negative 3 there. So get the sign of this negative 3 there. So it's going to be like this. Then you have cos x cubed minus 4 multiplied by sine x cubed minus 4. Like that. So here we can see, oh, this is y prime that we're finding. So we can see that this can also be simplified as just negative 6x squared cos x cos x cubed minus 4, and then sine x cubed minus 4. So this is the solution for this question. So you need to know how to take care of this power there. Because if you are not careful, you can just go directly and get it wrong. Yeah, I think we're going to end here for today. We're going to end here. Tomorrow we'll do question 6, 7, and 8. Since question 7 is just one question. Yeah, so it's going to just, I mean, question 7, I've not even put it here. Question 7 is just one question, so it's not going to take us a lot of time. So we'll do question 6, 7, and 8 tomorrow. And then we're done with differentiation. The other day we'll start integration. So I'm going to send these videos in a few hours from now, and I apologize for not sending the previous videos earlier yesterday, but I'm going to send them. I promise that I'm going to send them today. I'm going to send first the ones that I didn't send yesterday, and then by the end of today, I'm going to send even this one. Yeah, so see you tomorrow. If you have no questions, see you tomorrow in the next lesson that we're going to have.